In this problem, we're given a point charge Q1 that has a value of 50 microcoulombs and a point charge Q2 with a value of negative 15 microcoulombs, and we're told that these are 1 meter apart as shown in this diagram. And it wants us to find where a third charge, Q3, with a value of 25 microcoulombs, must be placed so that the net force on Q3 is 0. Well, first we need to decide if Q3 is going to be to the left of Q1, in between Q1 and Q2, or to the right of Q2. I'll start by drawing if the charges are positive or negative. Q1 is going to be positive, and Q2 is going to be negative, and Q3 is positive. So now I'll look at what happens on the left side. I see that Q1 and Q3 are both positive, so Q3 would be repelled to the left. And I see that Q2 is negative, so Q3 is going to be attracted to the right. But Q1 has a higher magnitude than Q2, and Q1 is always going to be closer to Q3. So no matter what, there'll never be a point in the distance where the net force would be 0, because Q2 will always have a lower magnitude and will be farther away from Q3 than Q1 is. So for that reason, there's no point left of Q1 where the net force on Q3 would be 0. So now let's look at what happens in the middle here. Well, Q1 is positive and Q3 is positive, so it'll get repelled to the right, and Q2 is negative, so it'll get attracted to the right. Now, since both of these forces are in the same direction, there is no chance that they're ever going to cancel out because they're not opposing each other. So they can't be in the middle, so Q3 must be on the right. Now let's see if this makes any sense. So Q2 is negative, so it's going to be attracted to Q2, and Q1 is positive, so it's going to be repelled from Q1. So there will be a point to the right of Q2 in which Q3 has no net forces acting on it. I'll call this distance R, and I know there's a point here because Q1 has a larger magnitude than Q2. So despite Q3 getting closer to Q2, meaning that the force get higher, it is also getting closer to Q1, and since Q1 has a higher magnitude, then it means there's going to be some point, probably really close to Q2, in which these forces will balance. Now I'll just label these forces. It's going to be attracted to Q2, so I'll call this F2, and it's going to be repelled from Q1, so I'll call this F1. And now I'm ready to state Coulomb's law. Coulomb's law is F equals K, which is a constant, times Q times the other Q over R squared. So I know that F1 is going to be equal to F2 because there has to be no net force acting on Q3. So I'll write F1 first. It'll be K. And F1 is supplied by Q3 and Q1. So my Q's will be Q1 and Q3. And the distance will be the distance from Q1 to Q3, which is 1 meter plus R. So on the bottom, it'll be 1 plus R squared. And F2 is going to be K, but this time it's going to be Q2, and it's going to be Q3. It's going to be over R squared, because the distance from Q2 to Q3 is just R. Now these K's are going to cancel out, and the Q3 is also going to cancel out. Now I'm going to cross multiply this, and I'll get that Q1 times R squared is equal to Q2 times 1 plus R squared. I'll write this up here. It'll be Q1 R squared. Now I'm going to expand this 1 plus R squared. It'll be Q2 times R squared plus 2R and then plus 1. So it'll be Q1 R squared is equal to Q2 R squared plus 2rq2 plus q2. I'll get that q1 r squared minus q2 r squared minus 2r q2 minus q2 is equal to 0. Now I can plug in some numbers for q1 and q2 to simplify this down to just a regular quadratic. But first I need to do a unit conversion. So 1 microcoulomb is equal to 10 to the negative 6 coulombs. So q1 will be 50 times 10 to the negative 6 coulombs. And q2 will be, I'm just going to write 15 because we already accounted for the negative with this part here, setting F1 equal to F2. So it'll be 15 times 10 to the negative 6 coulombs. Now I can plug that into here. So it'll be 50 times 10 to the negative 6 r squared minus 15 times 10 to the negative 6 r squared minus 2r q2 minus q2 is equal to 0. Now I'm going to make myself some room. So it will be 35 times 10 to the negative 6 r squared minus 2r, and it'll be times q2, which is 15 times 10 to the negative 6. It'll be minus q2, which is, again, 15 times 10 to the negative 6. And this will equal to 0. I can simplify this. It'll be 3.5 times 10 to the negative 5 r squared minus 3 times 10 to the negative 5 r minus 1.5 times 10 to the negative 5. This will be equal to 0. Now you can use the quadratic formula or plug this into a graphing calculator and solve for r by getting the x-intercept, and you'll find that r is equal to 1.21 meters, and this is to the right of q2. And so that is your final answer. Thank you for watching.